Yeah, it doesn't seem to be live yet. Ah, now it is.
It is?
Good.
Perfect.
Perfect. Thanks a lot, Suru. Okay, maybe we can start. Welcome everyone to this workshop on scalable development of low-code artifacts. My name is Juan de Lara. I work at the Universidad Autónoma of Madrid in Spain, and I would like to welcome you, all of you, on behalf of the lowcomote project. Right. So just a few words of introduction. Of course, you all know what's low code, but just in case, quoting Wikipedia, a low-code development platform is a software that provides a development environment used to create application software through graphical user interfaces and configuration instead of traditional hand-coded computer programming. And so this way of development had an impact. And actually, in 2016, Gartner predicted that by this year, 2020, at least 50% of all new business applications will be created with high productivity toolsets. And they also forecasted an increase for companies developing low-code platforms to over 21 billion over the next 4 years. I mean, by 2020 again. So if you look at the ecosystem of low-code development platforms, you find many proposals from big players like Google, Amazon, Microsoft, and so on, but many others, Mendix, OutSystem, Salesforce, and many more of them. You name it. So if we look more in details, what are the typical features of low-code environments? We can see that most of them are based on the cloud. And the reason is because this simplifies many things. It simplifies both development, configuration, but also deployment for execution is just on the cloud. Also because many of these environments are targeted to citizen developers. So these are developers that are not really professionals, but they want to have applications quickly for their business. And so they don't use general or programming languages like Java, but they normally use graphical languages, forms, configurations, and so on. And of course, if you are like me, you have a background on software engineering and on model-driven engineering, you realize that actually low-code shares many objectives and ideas with model-driven engineering, right? In NDE, we want to really create automation solutions for creating software with more productivity, right? And typically we do so using, sometimes using domain-specific languages, either graphical or textual. But even there are many similarities, there are also some differences too. So many NDE solutions, they are not really cloud-based. They are, for example, based on Eclipse, for using desktop applications. And also some NDE solutions, they don't target end users, they target developers or engineers, especially within the Eclipse ecosystem. But we will see also today that very interestingly, Eclipse and other IDEs are also moving to the cloud. So we'll see some synergies here. All right, after this brief introduction, a few words about the lowcomote project for those of you that are not familiar with it. Lowcomote project is an European Union project. It's actually an innovative training network from the Marie Curie program. It started in 2019, will last for 4 years, and we are 14 partners across Europe, 5 academic and 9 industrial. So the main goal of this project is basically training researchers, 50 of them, on enabling technologies to create low-code platforms. And the technologies that we focus are basically model-driven engineering, mostly, but also cloud computing and machine learning. And in addition to produce PhDs, PhD theses, so the idea is also to have to create a common platform and to develop components for an ecosystem that will allow to create low-code engineering platforms. And also the focus will be on scalability, so that these components will scale to create and model large applications. And actually, scalability will be the topic of today's workshop. So the idea is to have a look at techniques and technologies that will allow developing low-code platforms supporting scalable modeling of applications. So we will see today we have a very exciting program where we will see a lot of methods and techniques and building blocks that we will be able to use to develop such platforms. And we will also see examples of current low-code platforms. So we have an exciting lineup of speakers from industry like TypeFox, Gitpod, Eclipse, Axelians, and Newground, and also academia. We will have speakers from the University of Linz in Austria, IMT Atlantique in France, and the University of Montreal in Canada. This is the agenda. You have the agenda on the web here. We will have 2 sessions in the morning where you will see all presentations will be 40 minutes. So the idea is to have more or less 30 minutes for the presentation itself, and then 10 minutes for questions. We will have at 11, we plan to have a break. We will not cut the transmission, so you can stay here, well, either grab a coffee and cookies, or stay here and have more extended and formal discussion. Then we will have a slot for discussions at the end of the morning session, and we will have a lunch break if you are watching from Europe. And then in the afternoon, we will have the 3 talks, and we will finish with a slot of discussion and wrap up. I would encourage you to have an active participation and to ask every question that you would like to ask. If you are in this Zoom session, please use the Zoom chat, or even better, use your mic. If you are watching through YouTube, please use the YouTube chat. And you can also use Twitter using the lowcomote hashtag. All right, so I think we can move forward to the first speaker, Jan Köhnlein, and that will talk about text-first DSLs in the cloud. So I will pass the mic to him.
Thanks a lot. Can you hear me?
Yes, we do.
Very good. Thanks a lot, Juan, for that introduction. My name is, oops, that's not the first slide, this one. My name is Jan Köhnlein. I work for TypeFox and for Gitpod. And I'm going to present you text-first DSLs in the cloud today with the tool stack that we are using in our customer projects. And, oh, wait, I have to set up my Zoom correctly, such that I can see what I show. This is a bit better. Okay. All right. At TypeFox, we've been building domain-specific languages and modeling tools for more than a decade. And this is our current tool stack. We are still on the text-first level for very good reasons. I'm also going to point out it within this talk. So for some reason, cannot. Oh, strange. So this is the goal. We are going to build a textual domain-specific language with a rich text editor. Rich means that we have content assist, syntax highlighting, and all this stuff. Because for domain-specific languages, you cannot really expect people to know how your language works. So they need a lot of help from the UI to get towards working models. We are implementing a small code generator because, I mean, that's the whole point in the modeling stuff. In the end, you want to execute your code and your models, but models don't execute. You have to convert them to code. So we write a code generator, and we will add diagram support because, yeah, I mean, this is a low-code workshop, so we have to at least cover it, graphics. But it's a very special way we do that, and I'm curious how you will anticipate that approach. We will embed the entire thing in a VS Code extension. Well, that's not actually cloud, you would say. Why VS Code extension? Well, first of all, if you really want your DSL to reach a very big audience, you should use for the #1 IDE, and that's currently VS Code, at least according to some studies. But on the other hand, VS Code extensions are also the way that we package up language servers today and can reuse them in Eclipse Theia. And Eclipse Theia is the new cloud-based IDE framework in Eclipse. And it's the basis of all the cool new technologies like Gitpod and Shay. Bless you. Why text first? Yeah, we've been experimenting a lot with graphics and text and stuff like that. And text has a few real benefits towards graphics. First of all, it's really fast to edit. So with a keyboard, you will always be faster than with your mouse or touchpad or whatever tool you use to build your graphical models. You will have very fast turnarounds. You will always see the entire model. There are no hidden details. So my experience, I have been in a lot of migration projects where we, for example, started with some UML models and then had to, transfer them into a more specific DSL. And in these models, there were always like ghost objects. So things that remnants from refactorings that didn't work and all that stuff. So there was a lot of garbage actually in these models that were just never shown because the tools didn't show them. So you won't have that with text in that way. One of the biggest benefits of text towards graphics is you can reuse your standard tools. If you're really a developer, you are used to Git, diffing, merging. You can use a standard text editor if your models get entirely broken and so on. You can store, version, merge your models easily without having to think about additional abstraction and GUI. And text has a higher resilience to errors. That means, well, in essence, it's not a high resilience because we easily get syntax errors, but they're very easy to fix, even outside of your current modeling tool. The cons are text is not really low code. So we're in a low code workshop here. It is code, but if you build DSLs, you usually raise the level of abstraction to a very high level. So that is actually the game. So you will maybe not really catch the non-programmers with a text-first approach. But still, it's very interesting why we do that, because we also think it scales a lot better than graphics. And yeah, the other disadvantage of text is that sometimes you get lost in the details because it's linear. Usually you don't use folding or hiding details and stuff like that. So you will have a hard time getting an overview on a bigger model that is spread across several files. But that can be mitigated by just adding graphical views on top of it. So this is a very maybe confusing slide about how we use our current technologies, this tool stack. So as I said, we are going to build a VS Code extension. That's the whole thing, will be packaged up in a VS Code extension, and that has different parts. So now I'd really love to have a mouse pointer, but I can't somehow get one. Okay. So a VS Code extension has some kind of configuration part written in JSON. That's on the top left. A manifest, editor configuration, and so on. And then it usually has some kind of code for activation and deactivation of the extension. And then we are going to build a language server. A language server is something that it's actually an invention of Microsoft VS Code. It's their internal API, how they hook in the the smartness or the specificity to a specific language into a very generic text editor. And that is a protocol that even allows to implement the language server in a completely different language than the rest of the system. And then another specialty of VS Code is if you want to have additional views, things like that, that are not text-based, you have to create a web view. And that is another separate application that is embedded in your browser-based application and communicates with the rest through a very thin interface. So let's have a short look how a VS Code extension configuration part looks like. The core of it is an extension manifest. A VS Code extension is an NPM package. So if you're not into JavaScript development, NPM is like, if you're coming from Java, it's like the Maven of JavaScript. So there is a big repository with reusable components that you can just refer to, and it will be automatically downloaded to your system, to your development environment when you need them. And apart from some meta information like name and so on, publisher, this one, the NPM package manifest for a VS Code extension also can contain contributions, and these contributions are languages. So you see the contributes languages and the states language that we're going to use as an example here, an example for state machines. And it can also provide grammars, which is for syntax highlighting, which is completely client-side in VS Code. Client-side means in the editor and not on the language server. Yeah, so that's basically it. The last line is main pack states extension. That is, where the entry point for the extension is when it is being loaded. Syntax highlighting is client side. Maybe I don't get too much into the details here. VS Code extensions usually use the text make grammar syntax that is based on regular expressions, and a lot of rules are matched and then mapped to some style constants that are internally again mapped via the themes and so on to like font styles and colors and things like that. Okay, the language server protocol is actually a pretty cool thing because VS Code offers this very generic text editor that you can hook in the smartness of a language. And it's a protocol, as I already said, so you can implement this smartness in any language you like. Why is that? The reason for that is that the implementation you need to feed these services, like give me content assist at a specific place or follow this link, is usually, so the calculation is usually the same that you would do in a compiler. So language server, you can look at the language server as an extended compiler that has several hooks within the compilation process, gives you access to, for example, the symbol table of your language in order to follow links. And compilers are usually written in the language that they compile. So it's a good idea to have a separation here as a protocol and not just as an API. But how would you write a language server? It sounds like a lot of work. And this is where Xtext comes to our help. Xtext is an Eclipse open source framework. And it's been around for quite a while now. Very mature. It scales like hell. So you can really build very big models as long as you separate them in various files. And it has an incremental code generation mechanism and so on. So it's really mature and good. And the key point on an Xtext is you start with a grammar that looks pretty much like an enhanced Backus-Naur form grammar with a few additions. And from that grammar, Xtext can generate a language server. And that language server will then be hooked into the extension and serve the text editor in VS Code or Theia or whatever you use as a client. So this is the entire grammar for this little state machine example here. You see we have keywords like state machine, state, and event. These are the strings. And then we have calls to other rules like the ID rules. We have assignments. That means if that rule matches the returning value should be assigned to a feature in the AST model, like name equals or states plus equals. And one specialty is in the last line of this grammar. Xtext also allows you to define cross-references. So a transition refers to an event and it refers to a state. And these event and state are not defined here at this place, but they're defined elsewhere and just cross-referenced from that specific thing. And that cross-reference syntax, from that, you can derive a lot of tooling, like follow links, rename refactoring, and so on. So as we have this cross-reference semantics already in the grammar, this really opens up for a lot of automation in this language server generation process. Okay, to execute your DSL, you usually write a code generator. I hope you can read that. It's a bit light. This is an example. We usually write these code generators in Xtend. This language has been derived by us as well, but it's a bit out of fashion. But it still is the best language I know for code generation because it has certain very nifty features. For example, it makes a difference between white space and gray space. So gray space is white space you just have because you're writing a template, and white space is what really goes into the output. So there's a very sophisticated mechanism to manage this kind of thing. But what you basically see here, you have an entry point, do generate, you get a resource. So Xtext actually creates an EMF model from your text files that are stored in the resource. And then you traverse the resource, and for whatever element you encounter, like state machine, you call to Java code or generate code and spit out some text. So this is basically how code generation works. Okay, let me give you a demo. So this is VS Code. Oh, I'm already too far. This is VS Code. You see, oops, that's a bit too big. So you see this a DSL. You see we have syntax highlighting already in place. You also see that the parser that's generated from the grammar is already there because syntax errors are immediately marked like this. Okay, what should it be? And it's also integrated here. So that all that smartness comes from the language server, as well as this highlighting, or when I control click, I follow to the definition of a cross-reference. And yeah, all that stuff. Even that I can rename this state to something. And you see it hasn't only changed this one, but also this one, because it's aware of cross-references and will automatically update cross-references as well. So this is really, really nice. Just from that, little grammar we've written, you get this very, very rich editor support. Oh, I forgot to mention the content assist, which may be the most important thing. So content assist for keywords here, event and state, but also for cross-references that match this location you are at in the text. Okay, so much for this demo. Okay, somehow I have a small technical problem. Let me stop. Wait. Can do it here. All right, can you still hear me?
Yes, we do.
Oh, okay, yes. Good. Yeah, just my headphone just disconnected for a second. Okay, so that's all nice. Oops. But in the end, we want to have graphics as well. So graphics, in this case, know them from UML. And they are graphical in the sense that they focus a lot of interconnections between elements and not so much about details and definitions on the individual elements. So it's much about transitions and not so much about the properties of states. If you want to build a graphical view or editor in VS Code, you have to use a web view. And a web view is, I mean, a VS Code extension is VS Code application is basically a web application running in Electron. So this is really a browser that you see here that browses a web application. And in that web DOM, there will be an iframe, and that is what shows your web view. And that web view runs in this iframe a completely separate application. So it's like the language server. You have a third service, a third like microservice that serves the diagram and has to communicate with the rest of the extension via a JSON-based API. So it can exchange JSON messages with the extension. All right, we have to decide for a graphical framework, and we use Sprotty. Sprotty is also an Eclipse framework. It's a web-based. It has a reactive architecture, and that was the main reason to build it. Reactive means it uses a virtual DOM technology, which is very popular you may know that from React or Angular. All these use virtual DOMs because actually updating the document object model, the DOM of a web application, is very expensive. What we do there is you create a shadow model of that, and you just make the minimum patches to the real DOM because it's so expensive. As far as I know, we are the first who did that for graphics. But that's also the reason why we're using SVG, which is part of the DOM and not so much a canvas API for rendering. The other speciality is that we have you see the circle on the right-hand side, we have a unidirectional flow of events. That means even if the user does an action, creates an action on the viewer, this action is transformed to the action dispatcher, and by that, maybe transformed into a command or sent to the outside and then executed on the command stack and then going back to the model. This is always the same direction, always the same flow of events. If you compare that, for example, with GMF, where they have like 3 models, they try to reconcile and try to enable you to make changes on the diagram model or the view model or the semantic model at the same time and then update everything else. This is very confusing and leads to a lot of errors in practice. But here we have a single flow of information, so it's always clear how events make their way through the application's components. And the third real sweet spot of Sprotty is it has a client-server application. As these components really communicate stuff via actions, and actions are like the events in Sprotty, but they're just JSON structures, JSON objects, and serializable. These actions can come from the viewer, but they can also come from an external source, and they can also be processed by an external source. And that opens up the entire architecture for a client-server mode, where the authoritative model really is located at a server, and that server can communicate via Sprotty actions with the Sprotty client that's running in a browser. And that's exactly what we're going to use. Sprotty has comes with a couple of adapters. Well, first of all, there's the Sprotty main thing for the diagram client code. Then there's an adapter for Xtext, which makes it very easy to generate Sprotty diagrams from Xtext DSLs. And then there's Sprotty VS Code to glue these Sprotty diagrams into a VS Code-based application. Sprotty uses a diagram model internally. We call that the S model, S for Sprotty, of course. And I mean, if you're into diagramming, this shouldn't be much of a surprise. We have a graph, and the graph contains nodes and edges, and nodes create ports and compartments and labels, and edges can also have labels. Actually, this is not hard baked into Sprotty. That's the default. You could use any kind of other model as well. Maybe if you're looking for timing diagrams or scatter plots or whatever. But for most applications that we target, they are nodes and edges, and this is a good default. The Sprotty model is completely serializable, and cross-references are established via IDs. So every element has an ID, and if it refers to another element, like an edge has a source and a target, this cross-reference is made via the ID of the source and target. A Sprotty application, so a client, a diagram client, mainly consists of a dependency injection configuration. You see here that you can bind some services like the logger, or even override some parts of the structure of this client, like the model factory. But it's also the place where you map these S model elements that I showed you on the previous slides to actual views. And views are like the figures, okay? They are basically functions that take in an S model element and spit out an SVG element. And in this example, you see that we configure elements that have the ID, the type graph, and they come in as an S graph, so as an S model element S graph, and they are being transferred to an S graph view. In addition to that mapping, you can also enable and disable some features on these model elements. That is a little bit like if you're into GEF or Eclipse modeling, it's like the edit policies. So it's a composite pattern of adding behavior to your figures in the diagram client. All right, so now we have a diagram config, and we have a language server. How do we wire the entire thing up? So first of all, the language server now has to provide us with a Sprotty model that can be then rendered in the client. And that is achieved via a diagram generator. So this is very similar to the code generator that you've seen before. And I'll show you that in a second. This slide is basically about this functionality. So on the right-hand side, you see the Sprotty client with the reactive cycle. And now we hook in, we plug in the language server from the other side. And that language server has some extensions to accept or dispatch actions, so Sprotty events. That means our language server needs two more messages to send actions in either direction. All that is already implemented for you in Sprotty Xtext, so that comes for free. And the other cool thing is, you've seen that this when I change something in the demo in the textual model, these there's a certain life cycle associated with the editor changes. So immediately the new model gets parsed, and errors are shown, and things like that. And that in that exact life cycle, the diagram generator hooks into as well. Okay, so this is basically the diagram generator. It takes our AST model from Xtext when it changes and converts it into an S graph, so an Sprotty model. Okay, and yeah, this is how it's hooked up. It's maybe a bit too detailed at the moment. So in order to wire up the rest, so now we have this, we have extended the language server with the diagram generator. We added the language extended the language server protocol in order to exchange actions, and now we have to connect the missing pieces, and this is done with Sprotty VS Code. And Sprotty VS Code basically allows you to well, it manages the different web views. So if you reopen the same diagram, you don't get a new web view, but the one that you already have. And it also does the communication. The communication works a bit like that. So imagine in the language server, so the text editor gets some change. The text editor change gets propagated to the language server. The language server reparses the new text and then triggers the diagram generator. That one creates a new Sprotty model. That one is created, is packed up into an action, Sprotty action. That Sprotty action is transported via LSP or LSP extension to the extension code on the VS Code side, the language client. That one, here we have an action message, so it should be forwarded to the right web view, to the corresponding web view. And that one gets the action message. It extracts the action and feeds it into its reactive cycle. So how does it look like? So this is the very same example. I can open this in a diagram. And then you see whenever I make a change here, like add a new state, oops. This change is propagated to the diagram. So this change is propagated to the language server. The language server creates a new S model with a new node and propagates that to the client, and that renders it. And now when I connect that thing, so I have to mention an event and then connect it to this one. Okay, you see the diagram is updated. That's another special thing about Sprotty. When you update the diagram, the changes are automatically animated. So if you're into graphical tooling, I would strongly suggest to have a look at animations, but because these make it much easier for a user to actually grasp what the model change actually is. Okay, so this is a nice diagram. This is also synchronized. That also comes by default. Whenever I click on a node, the respective text gets selected. Whenever I click on the text, the respective node gets selected. But there is more to it, and that's the last thing I want to show you. You may want to edit that stuff. So edit on the diagram level. How would you achieve that? So of course, you could now go the GMF or most diagram frameworks approach and say, okay, I'm here, so I want to change this name. Then I change the label name and then propagate that to the language server. And that one has to kind of figure out what a label change should be in the text model. And what we actually do here, we don't perform these model changes on the AST model, but we try to map them to language server protocol, to textual actions. So when I double click on that label, what actually happens is the same as if I trigger a rename refactoring on that state node. So rename this symbol. Okay. And that makes sure that my event flow is always text first. That means the text will have the ultimate truth, the authoritative state. And whenever I want to change my model, I have to do it via text changes. And the language server protocol gives me already some abstractions over these text changes, like rename refactoring. So I changed the name here to foo new, and you see it's updated. The same holds for adding new elements. So if I add a new state here, what actually happens is it calls this kind of code template for a new state. Oh, where is it? Somehow it's not shown. So you should see a light bulb here. Where is it? For some reason, it doesn't show up. So we have installed some code templates which allow you to create, like, scaffold certain elements in text. And that exact same thing is triggered when I just do when I use this pop-up menu to create a new state. Oh, let me show here. So All right. And well, for this, for the reconnection, there's a little bit more to do. So you have to add some language to a new action on the language server. So this is not as straightforward as the other operations that I just shown you, but it also can be done on the textual level. One last thing I want to highlight now is, all right, so in this diagram, you see everything, but you actually don't see everything. So that is the typical difference between text and graphical editing, because the events that we have up here, they don't have a direct correspondence in the diagram. They're just referred to as labels from the edges. So when I add a new event here, I can do that. And you see it's added here at the end of the text, but it doesn't have a graphical representation. So it doesn't end up anywhere in the diagram. And this is very typical. Usually a lot of information on graphics is hidden in property panels, in additional trees that may show which events are there, and so on. So a diagram is almost never showing you the entire truth, but it should be made for humans to read, because it's much easier to follow the references in this diagram than it is to follow references in text. So keep that in mind when you build your tools, that not everything will have a representation in a diagram, and you have to make sure not to produce garbage that no one really notices. Okay, I guess I'm almost at the end of my time. No, I really am. So I have a few more slides here. I can upload the slides after this talk on the development process, which is a bit more demanding than usually, because you're kind of developing 3 applications as one: the extension, the language server, and the web view. And yeah, that's all. The entire example is also wrapped up here in this GitHub repository. And maybe as a last action, whoopsie, sorry, that was too fast. I will show you the entire thing in the web. I just have shown you that in VS Code so far, so locally. This is the repository of this example. I can, on GitHub, I can use this Gitpod. This is our brand new workspace provisioning and IDE framework product in the cloud. So this will open on our infrastructure. We'll create a container that will run Theia, the Eclipse IDE that's web-based, and we'll start it on this repository, download this repository, and make it possible to work on that. Unfortunately, I'm in a, yeah, it should come up soon. So this is really my browser. I hope it's starting soon. It looks like yeah, here we go. So here you see the same example. It takes a while until the extension gets loaded. Now syntax highlighting has popped in, and now I can open this in a diagram, and you will see exactly the same stuff that I showed you on VS Code, because it's exactly the same extension. So it can just be reused as is in Theia, and by being usable in Theia, it can also be reused in Gitpod. All right, that's all I wanted to show you. Thanks a lot for your attention. And if there are some questions, I think I have a few minutes to answer them.
Cool. Thank you. Thanks a lot, Jan. Any question you would like to ask? Please feel free to use your mic, or if you are watching on YouTube, you can use the YouTube chat or even Twitter. So maybe I can, in the meantime, I can start. So yeah, it was a extremely nice demo. Yeah, I have one question. It's more of a conceptual thing, no? So you have shown text first DSL, so I think the rationale is very clear. So sometimes it's much faster to write text. And it also has an advantage, it's more scalable than graphics, right? Even if you have mentioned that in your graphical view, you can skip some details, right? So my question is, what happens when the text program, the DSL, is very large? So the graphics would be very large as well. Is there any way in Sprotty or in your approach to, I don't know, to separate into more than one view, or to do some kind of abstraction that you can handle so that you can handle big diagrams?
Yes. So that's basically two questions. How is the scalability of the entire thing? And let me start with the textual part. As for diagrams, we should always keep in mind that we are dealing with humans. So humans don't like text files that are 2 gigabytes length. And so what you usually do is split it up into multiple files. Xtext is very scalable in the sense that it does incremental code generation. So it looks at changes and what parts of the model are affected, and only updates this incrementally. And that also holds for the updates of the diagram. So if I just change a little thing in one part of the model and that doesn't affect a lot of diagrams, all these unaffected diagrams are not touched. The other thing is in terms of representation graphically. So does that scale? Does Sprotty deal with big models? Yes, there is a new feature that a colleague of mine, Miro, who is also leading the Sprotty project, recently built that made it possible to even render the floor plan of a chip, so of a microchip, which is pretty big. It has lots of connections and components with Sprotty. And it's a combination of a level of detail approach and clipping. So not rendering things that are not in the current viewport, and also not showing all details of all elements when the zoom level doesn't make sense to show it.
Thank you. I think we have a question from the YouTube chat, from Jesus Sanchez Cuadrado. He asked, is it possible to integrate the editor in an external website?
Yes, that's possible. The editor, the textual editor is basically Monaco from VS Code. We just kind of copied that over to Theia. It's open source, so that is completely legal. And that has the hooks for the language server protocol as well. In fact, we did another project to separate that out. That was called Monaco Language Client. You can have a look at that. In the meantime, we abandoned that because that enabled to plug in the language server directly into the Monaco editor. But now that we support VS Code extensions, we rather do that with the original Monaco stuff and the language server client that is provided by the VS Code extension host.
Yeah, because as a follow-up of this question, I noticed that when you use Xtext, you can target JavaScript libraries like ACE or code mirrors, things like that. So is it something additional that you did to support all this, or
yeah, there's also Xtext support for ACE and code mirror, and I'm not sure what state that is. I haven't used that for a while. I know that Item is also doing some kind of web-based stuff based on Xtext, so you might want to have a look at that as well.
All right. We have another question from the YouTube chat by Sasha Nison. Can I manually layout the diagram, or is it always auto layout? If I can, where are the coordinates stored?
Okay, in this example, I showed you coordinates are not stored because we're using automatic layout and for reasons of simplicity. Yeah, you basically have two options to store the coordinates. Either you add another model, like many frameworks do, where you store just identifiers of the elements and their coordinates. Or you could also persist the Sprotty model for that. Or you just store, if you want to have a single source of truth, you can store the coordinates, of course, in the DSL itself. So, I mean, you're free to add comments, for example, or annotations, or even make them first-class citizens in the DSL as well. That's all possible. We built that for customers.
Right. Okay, then we have questions also from participants in this Zoom meeting. So Arsene has a question, so maybe you can ask the question using your mic. Please, Arsene.
Well, I have a question. This is Luca speaking, Luca Brardinelli. My question is possible to, I mean, the change propagation is also only possible from text to diagrams, or also the opposite is possible?
Yeah, that's what I mean with the unidirectional flow of events. So you should make sure that you have one model that rules everything, that has the absolute truth. If you do a text-based approach like here in Xtext, it should be the text. So all changes you make should be executed on the text first. That means each user interaction you do in our approach should be mapped to a text operation, and then this text operation is propagated to the diagram again. So what I've shown you is when I double click on a label, it calls a rename refactoring on the text for the specific element at that location. And that one is then executed, and then the change is propagated. And that way we make sure to also cover all the cross references and things like that. So we completely rely on the text to work.
Hello, can you hear me?
Yes.
Yeah. My name is Arsene. Thank you for the good presentation. I'm wondering what's like. I'm used on when someone is creating a language such as Python, the way you structure it, the way you do it. What's the big differences between when you're creating language such as Python or JavaScript, and when you're creating a low-code platform such as the one you showed us?
Well, the main difference is that these DSLs are usually much smaller, and they're not built to solve every problem in the world, but specific to domain. For example, in this case, it was states. It's a very technical domain, but we also have, customers from all kinds of industries that have, where the domain elements are controllers, microcontrollers, or share bank financial things, assurance contracts, and so on. So you could really capture the knowledge of the domain in that language with the means of the language. That is the main point of DSLs. If you're doing general purpose language, you may want to have it, Turing complete, so it should be able to solve all the problems that are out there, and that's the most that's a difference. So DSLs are usually a bit leaner and don't have that richness in expressions or computability, but that's just a rule of thumb. It's not a necessity.
But that means you still have to do the Alexas and the parsers,
Exactly. Xtext helps you to do that. We also did general purpose languages with Xtext, like Extend, for example, the one that we use for the code generator is completely written with Xtext. So that scales also to bigger and more complicated languages. But of course, it requires a bit more work.
Yeah, thank you.
Okay, any other comment or question?
Yes, I have a question. I'm Alessandro. Well, currently I'm working in an Xtext grammar with Eclipse in EMF, and I had to override some class, some generated class. Then I had to make some test, and I also thinking and writing a formatter and a custom validator. How could I do that things with BS?
Okay. So the question is there Xtext support for VS Code? It's a good question. So there is very basic support for Xtext and also for Extend in VS Code. VS Code also has a Java language server. So most of that should be possible, but it's not very convenient. What we actually do is we generate these, I mean, it's a separate application anyway. So we currently still use Eclipse to develop the DSL and the language server, but then hook it into VS Code and develop the extension part in VS Code and the Sprotty part as well. We can also do that in Gitpod because Theia also supports a lot of that, but with the same limitations. So Xtext is not really ready for web-based development, developing Xtext. But we are working on that. So we are thinking about changing that a bit, maybe extending the language server, maybe building a new kind of simpler Xtext that is based on web technologies and that could be better integrated tooling-wise into the development process.
Thank you very much.
All right, any other comments? We are a little bit out of time, but we have Slack at the end, so there should be no problem. Comments or questions? All right, if not, then thanks a lot, Jan. It was an excellent talk. Thank you very much.
Thank you
for all the insights you provided. And so